Hello and welcome class. So we are going to start a new chapter of class 9 NCRT and the name of this chapter is Gravitation. Okay, in previous chapter we have talked about forces. In this chapter we will learn about a new force which is gravitational force, how a scientist named Newton discovered about it, what are the laws, what are the principle this force follow and how it is useful in our daily life. This will be the first part of this chapter, and in second part we will talk about liquid pressure. Okay, how we can float on the liquid, why large ships don't sink but a small needle sink in the water. Okay, we will learn about a scientist named Archimedes and which type of principle he gave us regarding liquid. Okay, so there are two part of this chapter. In first part we will talk about gravitational force and in second part we will talk about the liquid force. So let's begin the chapter gravitation. So what is gravitation? First, let's do a small introduction of this chapter. So in previous chapter, force, we have learned about the motion of an object and force as the cause of motion. In chapter number 7, we studied what is motion, and in chapter number 8, we learned that force causes the motion, okay, or rest, because according to the first law of Newton, first law of motion, an object is in motion will remain in motion, and another object which is in rest will remain at rest state unless and until a new force is applied on it. Okay, we have learned that a force is needed to change speed or direction of the motion of an object. We have also learned that force changes the speed, okay, it changes the direction. We always observe that an object dropped from a height falls toward the earth. Okay, this is the pen. I dropped it from a height and it always dropped, it always fall toward the earth. Why it is so? Why any object which we release from an height, okay, or dropped from an height always fall towards the earth? Why not in opposite direction? So we will try to answer this question in this chapter. Okay. We all know that all the planets go around the sun. We know that there are 8 planets in our solar system and all 8 planets revolve around the sun. Okay. Why they do this type of revolution? In our everyday life, we observe the rotation of moon around the earth. So why moon rotate around the earth? Why it is happening? Okay. So we will also try to answer these problem in this chapter. In all these cases, there must be some force acting on the object. As we know that anything can't be in motion or in rest position without any force. So we know that there is some force associated with all these type of motion. Okay. Why this object is dropping? There must be any force which is, you know, pulling it towards it. Why moon is revolve around the earth? There must be any force. Okay, so we know that there must be any force acting in all these objects which causing them to do motion. Isaac Newton, a scientist, Isaac Newton, a scientist, could grasp that the same force is responsible for all of these. Isaac Newton say that a pen is falling towards the earth. Earth is revolving around the sun and moon is revolving around the earth. All these cases have same force. A single force is responsible for all these processes, and this force is called as gravitational force. Gravity or gravitational force is responsible for any object to fall toward the earth, earth to revolve around the sun, and moon to revolve around the earth. In all these three processes, and there are many more processes where gravitational force act, and in this chapter we will learn about gravitation and what is the universal law of gravitation. We shall discuss the motion of object under the influence of gravitation force on the earth. Okay, we will discuss in this chapter the motion of object under which force? Under gravitational force of the earth. We shall study how the weight of a body varies from place to place. Exactly, weight varies from place to place. Weight depends on where you are standing on the earth. This is very new for you. So we will study it also. Okay. And in the last part of this chapter, we will discuss the condition why any object float on the surface of on float on the surface of the liquid while some objects sink. Okay. Why this has happened, we will study about Archimedes principle. So this is the second part of the chapter. In first part, we will talk about gravitation and we will see that our weight changes from place to place according to physics. So let's study the first part of this chapter, which is gravitation. So we all know that moon rotate around the earth. Okay. This is our planet Earth. Okay, this is Earth. This is the path of moon, and we all know that moon rotate around the earth. Okay, moon rotate around the earth. Revolve. Revolve is the correct word. Revolve around the earth. But any pen, a pen like this, any pen or any object fall towards the earth. So any object in this space falls towards the earth, and these both the motion is responsible because of gravitational force. It is said that Isaac Newton, this is a very interesting story, that Isaac Newton was sitting under a tree and an apple fall on him, and the fall of the apple made Isaac Newton start thinking, okay, that why this apple fall towards the earth. Okay. So this is a very interesting story which leads to the discovery or the theory of gravitation. Isaac Newton thought, if the earth can attract an apple, can it not attract the moon? Okay. Moon revolve around the earth, and any object like that apple which falls on the on Isaac Newton made Isaac Newton think that an earth is attracting apple, that's why apple is falling towards the earth. can it not attract the moon? Can't Earth attract the moon and moon falls on the Earth? Is the force the same in the both case? He thought about it. He conjectured that the same type of force is responsible in both the cases. He concluded that revolution of the moon around the earth and falling of any object towards the earth, in both the cases same force is responsible for it, and he argued that at each point of its orbit the moon fall towards the earth instead of going off in a straight line. He argued that the moon always fall towards the earth instead of going in a straight line. Okay? Moon always revolve around the earth. It does not leave earth and go on a straight line path. He argued that at each point, moon tried to fall on the earth, fall towards the earth. So it must be attracted by the earth. It means that moon is also attracted by the earth, but we do not really see moon falling toward the earth. But we do not really see the moon falling towards the earth. And to understand this line, we will try to do one activity, okay, which is the activity of our chapter number first, 7th motion, in which we have tied a long string. We have taken a long string, and at the one end we have tied a stone, and we have hold the other end, and we try to move that stone in a circular path. Okay, so tie a small stone at one end of a long thread, hold the other end of the thread and whirl it round. Note the motion of the stone and then release the stone. Release that stone from your hand. What you are going to note. Okay. So same activity. This is a long thread. This is the stone, and you are trying to rotate this stone, giving it a circular motion. And then what you have to do after few seconds, just release the thread. What you are going to get. So before releasing the thread, the stone was doing circular motion, and after releasing the thread at this position, the stone moved in the tangential direction like the discus throw. Okay. When the stone was doing circular motion, its magnitude of velocity or speed is constant. Speed remain constant. Direction change continuously, or direction changes at every point. The change in direction involves change in velocity or acceleration, and this change in direction involves change in velocity for sure, because speed remains constant, but the direction is changing continuously, so velocity will change continuously. Change in velocity or acceleration. Is it clear, class? The force that cause this acceleration and keep the body moving along the circular path is acting towards the center. Okay. This object is trying to move in tangential direction, but a force which is acting towards the center is helping this object to move or to follow this circular path. Clear, class? So that force is always acting towards the center, and this force is known as centripetal force. Centripetal force. Okay. So this force always act toward the circle. Whenever any object is doing a circular motion, it means that its direction is tangential, but any certain force is always acting towards the center, which is known as centripetal force. Clear, class? So this force is called centripetal force. In the absence of this force, let assume you have released the thread. Okay, so you have stopped giving the centripetal force. And when you stop giving the centripetal force, what will happen? This object will follow the tangential path, okay, and go along a straight line. Okay, tangent. This is the tangent of the circle where you just release the thread, and this object or this stone will follow, flies off along a straight line. A straight line. So, in the absence of this force, the stone flies off along a straight line. And this straight line will be a tangent of the circular path. The straight line that meets the circle at one and only one point is called tangent of the circle. So we all know the definition of the tangent. When any straight line which touch the circle at one single point is called as tangent. Okay, and you will when you will release the thread, it means you have stopped giving the centripetal force. Then what will happen to stone? The stone will follow the tangent direction and move along a straight line and eventually follow. Is it clear, class? Same like a discus throw. So the motion of the moon around the earth is due to a centripetal force. Okay. There is a force between earth and the moon. There is a centripetal force, okay, which earth is providing to the moon. That's why the moon is rotating around the earth. Okay, and this force is a attractive force. So this centripetal force, which is an attractive force, is working like that thread which keeping this moon in a circular motion. There if there were no such force, if there were no such force, the moon would pursue a uniform straight line motion. If there would not be any centripetal force there, then what will moon do? Moon will pursue a straight line motion, and we have seen that a falling apple is attracted toward the earth. So it is clear that that force which attracts the apple towards the earth is responsible for moon to revolve around the earth. Both has same force included, okay, and that force is an attracted force. Now this is the answer of first question, that the motion of sun around the motion of earth around the sun, the motion of moon around the earth, and falling of any object towards the earth includes same force. Okay, and that is an attractive force, a centripetal force. So this was the answer of first question. Now question number 2 is, we have seen that the apple attract the earth. attracted by the earth. Does the apple attract the earth also? It means the question is, you will always stick towards the earth. It means you are attracted towards the earth. Does the earth also attracted towards you? And if yes, why? And the answer is yes. According to third law of motion, every action has equal and opposite reaction. And if you are attracted toward earth, then earth is also attracted toward you. But you can see this pen is attracted toward earth. Okay, so this pen is falling towards the earth. And according to third law of motion, the earth is also attracted toward this pen. Then why we can see only the motion of this pen, not the motion of earth? And the reason is the mass of earth is so large. Okay, the mass of earth is so huge that it cannot move any place. So, and the mass of this pen is very, very, very small in compared to the mass of earth. That's why this object is falling towards the earth, not the earth is falling toward this object. So, answer of the question number 2, that the earth is also attracted toward the apple. The answer is yes, and reason is third law of motion. Okay, class? And because the mass of earth is so huge, the earth will not do any motion. This object has to move towards the earth. Is it clear, class? The mass of an apple is negligibly small compared to the mass of the earth. So we do not see the earth moving towards the apple, but we can easily see apple moving towards the earth. Extended the same argument for why earth does not move towards the moon. Okay, moon also attract earth with the same force uh, on which earth attract the moon, but the mass of moon is very small compared to the mass of the earth. That's why we cannot see the motion of earth towards the moon, but we know that moon is falling towards the earth. Is it clear, class? So this is the answer of question number 2. In our solar system, all the planets go around the sun. Okay, it means that there is a centripetal force existing between sun and other planet. Let's suppose Jupiter. Okay, so there is a centripetal force on each planet applied by the sun. Okay, that's why other planet is also revolving around the sun. From the above fact, Newton concluded that not only does Earth attract an apple and moon, but all objects in the universe attract each other. So from this conclusion that any object is attracted toward Earth and Earth is also attracted toward that object, moon is attracted toward Earth and Earth is attracted toward moon, sun attracts all the objects, all the planets, and all the other planets attract sun. From this argument, all these facts, Newton concluded that each object attract other object. All objects attract each other. All objects in the universe attract each other. It means I am attracting this pen and this pen is also attracting me. Okay. And this force of attraction is called as gravitational force. Okay. The force of attraction between two objects, okay, is known as gravitational force. So, is it clear, class? So, this chapter begin with some simple question that any object falls towards the earth. Why moons revolve around the earth? Why earth revolve around the sun? So Isaac Newton, a scientist, thought about it when he saw an apple falling on him. He think he thought that this that apple was attracted toward the earth. So does it mean that moon is also attracted towards earth? And he find out the answer is yes. There is a force of attraction between earth and moon. If there was no force of attraction between earth and moon, then moon will do? Moon will fly off or move along a straight line, and it will not revolve in a circular motion around the earth. Okay, so it was clear to us that there is a force which attract object toward the earth. Then we learned that all planets revolve around the sun. So same concept as earth and moon apply on sun and other planet, that sun attract other planets. That's why other planet revolve around the sun. And by this fact, Newton concluded that all objects attract each other, and that force of attraction is known as gravitational force. So, in today's class, we have started the chapter gravitational force, and we have studied what is gravitational force. We first learned about centripetal force, that any force which is attracted towards the center is known as centripetal force, but all objects attract each other by a force. That force is known as gravitational force. In next class, we will continue the topic gravitation and learn more about gravitational force. I hope this class is clear to you. Now I will meet you in next class. Thank you.